Okay, so for this problem here, this is going to be example 2 from our textbook. So what they're wanting us to do for example 2 is they want us to take the function and look at the limit as x approaches 9 of x minus 9, all that over square root of x minus 3. So when we approach problems like this, there's three things we want to do. We want to find x approaching the value c from the left. So in our case, we want to find x approaches 9 from the left. We want to find x approaches 9 from the right. So what I'm going to do is I'm going to use x values. When you approach from the left, I'll use x values that are slightly smaller than 9. So we'll say like 8.9, 8.999, so like maybe 2 nines, 8.3 nines, and then maybe 5 nines. And we'll want to keep track of what are the function values given back for each of these x's. So as x approaches 8.9, what is 8.9 minus 9, all that over square root of 8.9 minus 3? What do those give back? Then over here, when we approach 9 from the right, we'll look at 9.1. And then we'll look at 9.01, 9.00, say 01, and then 9 point, lots of zeros, and then a 1. And we'll keep track of what is the function value returning in those situations. So we're looking at basically what we're doing here is we're plugging in numbers that approach 9 from the left and numbers that approach 9 from the right. And 8.99999 is really close to 9, but it's to the left of 9. 9.00001 is really, really close to 9. It's slightly to the right of 9. And hopefully, just like we did back in section 2.1, hopefully these two numbers are agreeing and are approaching something, and we get an idea of what that number might be. So let's try this. I'm going to type in into y1 in my calculator. I'm just going to type this function here in for y1 in my calculator. So parentheses, x minus 9, type that in, close parentheses, divide by, open parentheses, square root of x minus 3, close parentheses. So now I'm going to go to table, and I'm going to type in the x values I want. So when I put 8.99 or 8.9 in, I get 5.9833. When I put 2 nines in, I get 5.9983. When I put 3 in, I get 5.9998. And if I put 5 nines in, I get 5.999984. So the more nines I put in here, it looks like I get 5 with more nines after it. So it's looking like this is probably approaching 6. Because 5.99999, that's really close to 6. All right, let's see what I put in 9.1s and stuff. 9.1, I get 6.0166. Okay, so 9.01 gives me back 6.0017. Now if I put 3 zeros then a 1, I get, let's see here, what does that give me back? 6.4 zeros, a 1, a 6, and a 7. And if I put, see, 9.12345 and then a 1, I get back, whoops, that's weird, hang on, 2, 3, 4, 5, and then my calculator just says it's 6. So basically this is approaching 6, this is approaching 6, so we would say the limit as x approaches 9 of x minus 9 over square root of x minus 3, that equals 6. And they want us to look at this graphically and see if the graph makes sense also. So let's pop open Desmos here. And let's see, what do we got? It's x minus 9 divided by square root of x minus 3. Okay, so we were interested in what's going on at 9. So 9 is here. As we approach x from below, we get 5.99. When we get to 9 itself, we're undefined. That's okay though. It's okay to be, you can still have a limit even if you're undefined at a value. So we say, well, at 9 we're undefined, but what we're looking at for the limit is what are you doing slightly to the left? To the left, you're 5.998. What are you doing slightly to the right? Slightly to the right, you're 6.002. So you can see just based on the graph, your function is, let me grab this and just kind of write out what I'm saying. So based on this graph, as we get close to 9, so as our x's are pinching down on the 9 down here, we get the y values. From below, you're approaching 6. From above, you're also approaching 6. And even though there's an open circle here at 9, that's okay because the y values are approaching 6 from either side. So we can say we see it numerically, and here we kind of see the same thing happening graphically. So we'll stop on that one here.